Welcome to our professional development session on graphic organizers in science with emphasis of the use on smartboards.
What is a graphic organizer?
Good question. So, a graphic organizer is a way to organize information in a new visual format. It helps students move beyond language comprehension and into language production. Specifically in science, it's useful for developing specific academic language. It's good for gathering ideas, it's good for brainstorming with your peers, and of course it's good for making predictions for your upcoming experiments.
So why would you use a graphic organizer?
So, with a little bit of background information, according to Dr. Robert J. Marzano, there are several tiers of languages, with Tier 1 being basic words that you've learned growing up in an English family, Tier 2 being words that you would have only learned through attending school, and Tier 3 being academic words. So, we know that in our classroom we're going to have English learners and we're going to have ELL students. So, we have multiple different linguistic backgrounds, and so using graphic organizers can be a good way to scaffold both English and ELL students to achieve a higher level of vocabulary. In sciences, we want to develop academic vocabulary, which is that Tier 3. So we would like to connect the idea of visual representation through graphic organizers with the interactive element of smartboard technology. It creates an opportunity for students to collaborate with one another, it connects peers, and it creates an innovative way to brainstorm ideas and predictions. Students can present information in non-linear format, and they can learn from both themselves and their other peers through this method. So we're going to go through an example here. So this is the know, want to know, predict, and learn graphic organizer. So Janelle's going to come up and write down what she knows and what she wants to know about density, which will be the topic of today's presentation. While she's doing that, we're going to discuss the rest of the graphic organizer. So in this section, a student will write any predictions that they can make about the experiment that we're about to do. Here, once the experiment is done, they can come up and they can write down what they've learned through that experiment. Down here in the additional language task area is a place where they can write any academic language that they think will be relevant to this experiment and to this topic. So it looks like Janelle understands that heavy objects will sink, light objects will float, and that she wants to know, why does ice float? So this is one of our graphic organizers. We're going to show you another graphic organizer that can be used in a density experiment. We can cut this out.
We're going to talk about the prediction tree, which is a great graphic organizer to use right after KWPL. So in the middle, we're going to have our topic, which is still density. And Ted, do you want to come up and write a prediction about our experiment? We're going to have an experiment where students are floating different types of materials in water and making predictions about their density. So Ted just wrote that his prediction is wood will float. Awesome. So after groups go through and do this inquiry-based lab, they're going to come up and write their proofs or their evidence. And so as a group, we can see what information we've gathered individually and come together to organize it in this format. And again, we have the additional language task where we can go over academic language. So graphic organizers are important in a science classroom for facilitating diverse types of learning styles. So students who are visual learners will benefit from being presented information in various formats, linear, nonlinear, even pictorial, in a graphic organizer. Differentiated instruction is also supported in that a student could really use a graphic organizer in any way that suits their learning style and communication of learning. English language learners, or those with a language difficulty, would benefit from using graphic organizers like KWPL and the prediction tree because it scaffolds their learning. It can allow students to make connections between class concepts that would have been challenging to connect without a graphic organizer. For example, it can scaffold learning for learners with language difficulties to solve a problem or connect ideas without being limited by sentence structure or grammar. These particular graphic organizers can be used online by students and instructors as well, in other languages using different alphabets and characters to facilitate learners from diverse backgrounds. So a way to use this in science. Like in our demonstration, you can summarize and debrief an inquiry-based lab, a project, or a demonstration. Students can have a chance to work with academic vocabulary and concepts before, during, and after the lesson with graphic organizers. The prediction tree is also perfect for students organizing their own thoughts or collaborating with a peer, and organizing how their predictions connect to their classroom learning and future scientific investigations. Graphic organizers can guide small and large group discussions like we saw in our classroom example of density, and can be a functional, guided way to gather relevant information and start working on it.